So last two examples and we'll be able to wrap up this topic. And the example I'm going to take now, the equation I'm going to take now is one of the equations of motion discussed by Newton, and it is the V is equal to U plus AT. So if we are to check for homogeneity, we again need to go with the left hand side and the right hand side. With V, we need to come up with an equation that we know is correct, and I've chose the displacement on time, where displacement is measured in meters and time is measured in seconds, and quite simply those are the units for the left hand side. So for the right hand side we've got U plus AT. Now I need to discuss something here because this is stacked slightly differently. So when you see an addition of quantities, quantities can only be added if they have the same unit. So, for example, if we are adding 5 meters to 2 meters, then that will give you 7 meters. No problems there. However, if one of these units, then we cannot add up those two values, because 5 meters plus 2 seconds, what we're saying there is we're trying to add time to length, which doesn't make sense. So when checking for homogeneity, in such situations, what we're going to do is we're going to check that the units for U and the units for AT are the same. And if they are the same, they should be equal also to this unit on the left hand side. For this equation to be correct, then you need, say, a number here, which would be, this is velocity, right? 2 meters per second. And if we're saying that the answer for velocity should be a certain value, but in meters per second also, then we need to add this to yet another value in the same units. So say 2 meters per second plus 5 meters per second, that is going to give us a value 7 in the same units, in meters per second. So the only way for this equation to be homogeneous is if it's got the left hand side being, say in this case, meters per second, whilst all the units or all the physical quantities on the right hand side will always give us meters per second. For U, this is velocity, and we've already found the base units for velocity, which are the meter per second. We can just list that down. For AT, T is a base quantity, and therefore we know that that can be given in seconds. However, acceleration is not a base quantity, therefore we need to open that up, break that down further by using an equation for acceleration. And acceleration, I'm using change in velocity on time. However, whilst time is a base quantity, velocity is not. But velocity we've already broken down initially, so we don't need to keep on breaking this down, showing the examiner that we know how to open this up. Therefore, I can simply copy this unit instead of velocity here. So we're going to end up with a meter per second, and in the denominator we've got yet another second for that time, and here we end up with a meter per second squared. Those are the units for acceleration, therefore these can be copied just right under the acceleration, and we can actually simplify. So the second will cancel out one of the seconds in the denominator, and therefore we end up with a meter per second. So what we've got here is a meter per second plus a meter per second. Now remember, this positive sign here is there to add the values and not the units. So what this actually means is, say U is 6 meters per second and the value for T is 2 meters per second, then that will give us a value of 8 meters per second. So when we see units added or subtracted without the values, their answer is going to be a particular value, but with just one unit. So meters per second plus a meters per second, the values are actually being added, but the units are not. Their answer will be in those units. So the units on the base units on the right hand side are the meters per second, which is the same as that on the left hand side, and therefore we need to conclude our question with such a statement. So one final equation, and this time I'm going with an example that will not be homogeneous. And the equation I'm going with is a v is equal to u plus 2as. The actual equation has the v being squared and the u being squared. This is an incorrect equation, and we should come up with an equation that is not homogeneous, or rather the answer for this equation will be that it is not homogeneous in terms of base units. However, let's just assume that we do not know this and we are actually checking this out. So again, same thing, left hand side, right hand side. Left hand side is simple. We've been doing this over and over again. We've got velocity, and therefore we're going to go with an equation for velocity. In this case, it's displacement divided by time, and the units would be meters per second. For the right hand side, we've got u plus a 2as. Now, again, we've got an addition, so we just work these out separately. For u, that's a meter per second, that's velocity. We can just copy this down because we've already shown that we know how to break this down. For 2, that is a dimensionless constant, so no units there. For displacement or distance, this is the meter. It's a base quantity, therefore we can just state its units. However, the acceleration we need to break down further. And again, for acceleration, I'm using change in velocity divided by the time, and the velocity I've already shown in the same question that we know how to work this out. So just copy all of this value there. So instead of velocity, I'm listing down the meters per second, but next to that in the denominator, we've got the units for time, and we end up with the units for acceleration being meters per second squared. So all of this needs to be written down here next to the meter for the displacement, so meter per second squared, and therefore what we've got there is a meter per second plus a meter squared divided by a second squared. Now this is where we've got a problem. We can't add a meters per second to a meter squared second squared. This is a totally different unit than this. It's just like saying add 6 meters to 2 seconds, say. Totally different units. You can't add them up. This can't be a correct equation. So when you encounter such a situation, you can simply stop there. You can't simplify this further. What you've got on the left hand side is the meter per second. What you've got on the right hand side is the meter per second plus a meter squared divided by a second squared. And therefore we have to conclude in this case that the equation is not homogeneous in terms of base units. And this statement we need to state and mark that as our answer, because that is what we were asked for. We were asked to check whether the equation is homogeneous or not, so we actually have to give our own conclusion. If you found these videos helpful, I encourage you to subscribe to this channel and hit the bell icon so as to be notified whenever we post up new content. New content will be coming along, always targeted for A-level physics, and the next chapter we will be discussing will be vectors.